Bismillahirrahmanirrahim. Respected matriculants, Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be looking at the preparatory exam of 2022. And if you go through the questions, we'll begin at question 1, which is multiple choice. Question 1.1, we read, which of the following best illustrates balanced forces? So balanced forces are forces that act on a single object. So if you look at the answers that we have here, a person lifting an object from the ground, there's an object that's being lifted and there's gravity acting downward. So there's movement of the object. B, a big rock free falling to the ground. The rock is falling by gravity to the ground. The object is again moving downwards, and there's frictional force acting upwards, which is small. C, a light stationary object that is stationary, there's forces acting on it in such a way that the forces are balanced. So a single object that is stationary looks like a good answer to have. And D, a force on the box on the earth and a force of the earth on the box. Again, there's two objects involved, so that won't apply. So looking at the answer, the options for 1.1, the answer which best fits the question is, which of the following best illustrates balanced forces? So there are forces acting on a single object. So the best answer there will be a light stationary object. So the best answer will be C. So let us write it down in our book. Question 1.1. The best answer for us will be C. Alright, let's go to 1.2. So if you go to 1.2, the question is, an 8 kilogram box is placed on a rough surface as shown below. 8 kilograms, force of 16.5 newtons pulling to the right, and acceleration of 1.5 meters per second. If a force of 16.5 newtons is applied to the box as shown in the diagram, it accelerates at 1.5 meters per second to the right, that is shown. The frictional force between the 8 kilogram box and the surface is the frictional force between the 8 kilogram box and the surface is. So now here we'll have to figure it out, and we'll have to do a calculation. So we got an 8 kilogram box, 16.5 newtons to the right, acceleration 1.5 to the right. So let's see how we will do it. So what you should do in multiple choice is, don't just choose an answer, which one looks right. You have to do a calculation, then you must be prepared to do a calculation. So let's look at this one again. I'm just drawing on the right hand side here. Now just don't do it on your page. Do it on rather do it on a question paper if you have to draw something. You got that, you got your acceleration, and you got your friction. So let's put in our values. Our 16.5 is our force. Our force here is 16.5 newtons. The acceleration here is 1.5 meters per second squared. We must find out friction. So if we have to do the sum, we'll have to say F net is equals to MA. So your net force here will be your applied force, which I'll put as capital F, minus the frictional force, F friction, is equals to MA. So that will be 16.5. Let's just erase this for us. 16.5. So be 16.5 minus the frictional force is equals to M. What is the mass of our object? 8 kilograms. And your acceleration is 1.5. So if you have to put it here, it will be 8 times 1 comma 5. And then if we go further, if you have to work this out, we've got 16 comma 5 minus f is equals to 8 times 1 comma 5 is 12. And then minus f will be equals to 12 minus 16 comma 5. And then minus f will be equals to minus 4 comma 5. And then if we have to work out f, we take it further, f will be 4 comma 5. So let's look at this. Do we have an answer of 4 comma 5 newtons as the frictional force? Yes, so B is the answer. So coming back to our section, let's just erase our calculation. The calculation is very important, remember. It is not just Russian roulette. There's no just thinking of an answer by guess. You'll have to work it out. And after you do your calculation, we saw that the answer is 4 comma 5, so we can write it down. So 4 comma 5 was the answer for B, right? So let's write it down. Let's just double check that again. 4 comma 5 was B. So if you write this down, the answer there was 4 comma 5. So if you take 1.3 as our next question, the question is, a ball is dropped from a certain height above the ground and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it is dropped. Ignore all the effects of air friction. So looking at this, we see a ball is dropped. And if we look at the beginning of our graph, it's at 0 and it is dropped. So this is when it is dropped. And at A, to see the dotted line means from here it is dropped, it bounces. This A, B, C is a bounce. Then it hits, and from here it's on the ground. A to C it's on the ground, and then it raises above the ground. It reaches maximum height at D, then it goes back down, and then what happens here again? This is the bounce where it's attached when it is connected to the ground, and then it bounces up. It reaches maximum height again at this point, and then it goes down, and here it's basically reaching the ground. So they took down as negative, and then let's see what it says. Let's look at the question. A relation to the velocity time graph for a bouncing ball shown above. Which statement below is correct? Down is taken as positive. We see that it is going down and this is in a negative direction. So down taken as positive doesn't fit in. So look at B, down is taken as positive. So A and B automatically doesn't fit. So we can eliminate two answers from our answers that we can suggest. So we basically have to choose between C and D. A and B is definitely wrong. Excuse me. C, down is taken as a negative direction, that's correct, and the ball is at its highest position of its bounce at C. So we see that A to C is when it is bounced, C is when it's still on the ground, A, B, C is when it's on the ground. So C cannot be the answer. Let's look at D. Down is taken as negative, which is that is the right explanation, and the ball is at its highest point, at its highest position of its bounce at D. So at D it reaches maximum height, and we did say that from C it reaches maximum height at D, and here it turns direction and goes back down and hits the ground. So the best answer to fit here will be 1.3. 1.3, the answer is D. Let's write it down. 1.3, our answer is D. Let's write on 1.4. Go back to the question. Two identical solid spheres, each with a mass m, are traveling at a speed v, moving towards each other in an isolated system. The spheres have a head-on elastic collision. Elastic, right? Which statement is correct for the collisions as described above? We see that the kinetic energy of the object will be half mv squared, and energy is not a vector, so what we'll see is that the direction doesn't play a part. The spheres stick together on impact. It says elastic collision, so that first part won't fit into play. The second part, the total kinetic after impact is mv squared. So this is half mv squared for this the first object, and this is a half mv squared for the second object. So half mv squared plus half mv squared will give you 1 mv squared. So B is the correct answer. So here B will be the correct answer. Look at the next, the option C, just to make sure the total kinetic energy before impact is 0. No, that won't be the case. The total momentum before impact is 2 mv. That's also not correct. So the answer will be B, 1.4B. One point five. The mechanical energy of a moving object will remain constant if there is frictional force present. Then it won't be, that's an external force. The problem is that won't be the case. A wouldn't be right. B, there's only gravitational force acting on it. If there's only gravitational force acting on it, the gravitational force will pull it down, and then the potential energy will be converted to kinetic energy as it moves down. So B looks like an option. C, only kinetic energy remains constant. No, mechanical energy, EM is equal to EP plus EK. So C doesn't fit. Only gravitational potential energy remains constant. That also doesn't fit. So the best answer here will be B, because when only gravitational force acts on it and there's no external forces like friction, then the potential energy is converted to kinetic energy as the object moves down. So 1.5, the answer will be B. Okay, 1.6. A train is moving at a constant velocity of 10 meters per second while sounding its whistle, which has a frequency of 500 hertz. So the frequency of the source is 500 hertz. Take the speed of sound in air at 340 meters per second. What frequency will be heard by a man sitting in the train? So if a man is sitting in the train, there is no movement towards or away from the source, so you are at the source, so you will hear the sound of the source. So the sound of the frequency of the source is 500 hertz, so the man sitting in the train will also hear the frequency at 500 hertz. So the answer, from looking at the answers that we have here, more or less no sound at all, A is the answer, right? So 1.6, the answer is A. Let me just erase this additional points. One 1.7, let's look at our question. The diagram below shows a point P at a distance r from a charged sphere Q. So here's Q, the charged sphere. P is your positive test charge that's put at a distance r. The electric field strength at point P is, electric field strength, if you look at the definition of electric field strength, E is equals to, if you're not sure, you can go to the end of the data sheet, but you should be knowing this by now. Let's just go there. Let's see if we can find electric field strength. Electric field strength, E is equals to E is equals to KQ over R squared. So that's where we are. E is equals to KQ over R squared. So let's go back where we are. is equal to KQ over R squared. So look at A and B, directly proportional to R. So it's R is equal to KQ over R squared. So it's the not directly proportional, it will be inversely proportional to R squared. So directly proportional to R, directly proportional to the square of R doesn't fit. So A and B is automatically wrong because it's not directly proportional to R. Is equal to KQ divided by R squared. So it's inversely proportional to R squared, right? Then between C and D now we must make a decision. Inversely proportional to the square of R to the right, the electric field strength at point P is inversely proportional to R to the right, inversely proportional to the square of R to the left. So now, how are we going to choose that? If you look at P and you look at Q, Q is minus 3 newtons, minus 3 nanocoulombs, and P is a positive test charge. So P is positive and Q is negative. So there will be a type of an attraction. So it will be towards the left. So the answer 1.7, the best answer would be D, inverse proportional to the square of R to the left. The answer would be 1.7 would be D. Okay, let's go 1.8. Which of the following statements about an AC generator is true? An alternating current generator, the minimum potential difference produced is not 0 volts. The EMF, it does get to the A is wrong because at some point when it's rotating, there is a 0 volt because of the changing the voltage and the current and the EMF, all that. The EMF produced decreases as the number of windings in the armature increase. The EMF produced is constant if you're looking at the equation. The maximum value of an AC can be increased by increasing the period of the rotation, not necessarily the period. D, the maximum value of an AC produced can be increasing by increasing the speed of the rotation of the coil. So you can increase the maximum value of the AC by increasing the speed of the coil. So D seems to be the best answer. So 1.8, the answer will be D. 1.9. So you can increase the EMF by increasing the speed of the rotations. That's 1.8. 1.9. A battery with an internal resistance is connected. A battery with an internal resistance is connected to a fixed resistor R. A voltmeter is connected across the battery as in diagram A. So if you look at diagram A, there's a voltmeter, you got your battery, internal resistance, voltmeter, resistor in series. The battery is replaced by one with the same EMF but with a larger internal resistance as shown in B. So here we see that the internal resistance is 0,2 ohms and it is being replaced by an internal resistance of 0,4 ohms. In diagram B, how would the voltmeter reading and the current through the fixed resistor change compared to diagram A when the switch is closed? So how will the voltmeter reading be affected? So here with the lost volts, because we have a lower internal resistance, the lost volts in diagram A will be a certain amount, but because there's a greater internal resistance in diagram B, the lost volts will be greater. So the voltmeter reading won't be 12 volts, it will be much less than the reading in diagram A. When the switch is closed in diagram in B, the voltmeter will be less. And the current through the fixed resistor, because the voltmeter reading is less, the current will also decrease because the total resistance in the circuit has increased. So both will be decreased. So the voltmeter reading will decrease and the current through the resistor will also decrease. So the answer for 1.9 is A. So let's just write it down. The answer for 1.9 is A. So that's the question 1 that we looked at. when we answered all the questions. And then 1.10, they said there was a problem in the sum in terms of the answers. So we won't go through 1.10 because they did not give any marks for the sum of 1.10. We will now look at question 2.